Hello everyone. So this is my chemistry video on chapter 7 and 8. It's about bonds, ionic and covalent. I'll be doing the level 4 question, so let's get started on that. Alright, so the first order of business is to find out what the X is right here if it's ionic compound. So we can use our periodic table right here. To find the first one. So Be, right here, beryllium. So basically that would have a charge of +2. So Be2 plus, because it has 2 valence electrons and you need to get rid of those 2 to get the noble gas formation. So then in order X, since it's 2, in order to cancel out, it would have to be in group 7, because it would be in group 7 because 7 needs to add 1 electron in order to reach the noble gas formation, so it'll have the charge of a 1 negative. And because of that, if you have 2 of them, because there's 2 right here, there will be 2, so then it'll be 2 negative, and the 2 negative will cancel out the 2 positive, making it a possible ionic compound. So then this would be in group 7. For this one, aluminum 2, X3. Aluminum is right here, and then in order to reach the noble gas formation, it would need to lose 3 electrons. So then I'll make it aluminum, which is Al 3 plus, because it loses 3 electrons, so it's positive by 3. So then, in order, since X, there's 3 X's, right? That would be in group 6. Because if you think about it, 6 needs 2 electrons to get to the noble gas formation. And since 6 needs 2, and then there's 3 times 2, 3 times 2 is equal to 6. So then it'll be -6. Let me move over here. It'll be -6 plus 6, because aluminum would be 3 times 2, because there's 2 for the aluminum, and that'll be equal to 0. So then aluminum would be group 6. And then for the last one, which is XO, so we know O is oxygen, right? So then oxygen is right here, and that has a charge of 2 negative, because it adds 2 electrons in order to reach the noble gas formation. So anything that's 2 negative would need 2 positive to cancel it out to make the ionic compound. So that would be in group 2, because it would lose 2 valence electrons to be 2. So then that would be group 2. So here you got it. So for Be, it was group 7, for aluminum, group 6, and for oxygen, group 2. Moving on. Alrighty, this next one took me some time to think, but okay, I'm ready. Indicate the hybrid orbital is used in each carbon atom in the following compound. The carbons are numbered for easy reference. Okay, so let's start out by first looking at this diagram. So let's do number 1 first, right? Number 1. So this carbon, you can see it has 1 hydrogen bond right here, and then a 3 bond with this carbon. Because it has that 3, the orbital would be an sp bond, just sp. And then since number 2 also has a 3 bond with oh wait, sorry, I've been saying 3 bond, I meant triple bond. Anyways, since it also number 2 also has a triple bond with the carbon, it will be also sp. Since this carbon number 3 is in the middle, it's in the middle, and it has a single bond here, a single bond here, a single bond here, and a single bond here. So that means it has 4 single bonds, and that would make it into an sp3 orbital, hybrid orbital. And then for number 4, since it has a double bond right here with the oxygen and 2 single bonds, it would be an sp2, because it has this double bond with the oxygen. Then this fifth carbon right here, since it has 1, 2, 3, 4, 4 single bonds, it would be an sp3 because of those single bonds. So yeah, that took me a while actually. Yeah. So yeah, moving on. Alrighty. So the next part says draw the electron dot structures for PCl5 and SF6. Hint: these compounds are exceptions to the octet rule, so we can keep that in mind when we draw them. So for this first one, let's start with PCl5. Okay. So we can start out by putting P in the middle, right? And since there's 5 Cl's, we can surround this P with 5 Cl. So chlorine, sorry. It's chlorine. Okay. And we know that each of these chlorine have to be added to the P, or connected or bonded to the P. So let's find out how many electrons total there should be in this bond. So if we go back to our periodic table, sorry, this is kind of messy. Back here, we have P, which is phosphorus right here. That has 5 valence electrons. And we have chlorine, which has 7, right? So then we can do the math right here. 5 plus 7, and then there was 5 chlorine, so 7 times 5. 5 plus 7 times 5 would be 35 plus 5, which is equal to 40. Right? Yeah, so there's 40. So let's go back. Okay. Alright, so we can start putting the electrons around the bonded atoms. So here we go. 1. Oh, is my pen on? My pen is not on. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So we have 30 so far, right? And we have to get 40. So we can remember that these bonds right here, these are single bonds. Single bonds have 2 electrons each, so that's 2, 4, 6, 8, 10. So 10 plus 30 is 40. So right here is your electron dot structure for PCl5. I can make that darker for you. Just wait a second. Yeah. Alright, so as you can see here, each of the chlorine gets an octet, but the phosphorus actually gets 10 octet. I don't even know. Anyways, but yeah, it does not follow the octet rule. Okay, moving on to the next one. SF6. So we can write that out. S and then F. There will be 6, right? 1, 2, 3, 4, 5, 6. So F, 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 F. So F is fluorine, and fluorine is in the 7th, group 7. So then, and then S is sulfur, which is in group 6. So then it'll be 6 plus 7 times 6, which would be equal to 48. So then we can count those in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. And then we can count these or the inside the single bonds. So that would be 2, 4, 6, 8, 10, 12. So then be 12 plus 36 would be equal to 48. So then you can tell that this would be right. So then it would look like boom, boom, boom. It would look like this. This would be your final dot structure for sulfur hexafluoride, I think. And yeah, thanks for watching. Bye. Oh, and by the way, I guess it's important to mention, this was made by me, Michael Matsuda. Yeah, I didn't say that in the beginning, but whatever. Bye, thank you.